So let us start with a traversal algorithm, DFS, which is depth first search. So DFS is a graph traversal algorithm. And here we start from any node and we go to all its connected nodes and traverse them and depth wise. So let us see what do I mean by depth wise. So suppose we are at starting, we consider our starting node as 1. We can start from any node, but suppose we are at 1. Then we will go either to 2, either to 5. Then if suppose we are at 2, then we will go till 3, and then we will come back to 2. Then we cover 4. Then again we will come back to 2. Then we will go to 5. Then go to 7, and 7 is connected to 6. We will go to 6, and now 6 can go to 5, but 5 is already traversed, so we cannot. We again come back to 7, then from 7 to 5, and as we know that 5 has another children 6, but it is already 5 has another connection 6, but it is already been traversed, so we cannot go to 6, and our traversal is over. So how we did that? We went to 1, 2, then 3, then 4, uh, then 5, then 7 and 6. So this is our traversal. Now uh, we can traverse in many different ways. So just let me clean this. Okay, so another traversal can be, suppose we start from 1, then we go to 5, then to 6 or 7, anything, but we are just checking all possibilities. Then from 6 we had to go to 7. 7 will go to 5, but it is already visited, so we cannot. Then we come back to 6, 5, then again to 1, then go to 2. Then from 2 we can go to 4. Just in last time we did that, from 2 to 2 we went to 3, just to make another possibility. We are going to 4, nothing after 4, so just come back, and from 2 go to 3, and nothing after 3, come back to all the edges of 2, all the connected nodes of 2 are now uh, traversed. So again come back, and all the connected edges, connected nodes of 1 are also now traversed, so came back. So this is another traversal. Now unlike trees, in trees what we used to do, we we used to start from first node, root node. But in graphs, what we can do is, let us suppose we are starting from 6. This might be also the case, like our starting node might be any node on the graph. So we are at 6, then we can follow two routes, 7 or 5. Now let's go by 7. So 6, 7, 7 has another connected. So let us see. 7 has two connections, one with 5, one with 6. But 6 is already visited. That is why we are only choosing the ones which are not visited. So we are going to 5. 5 has two connection, 7 and 6. They are all visited. So we have to go to 1, 1, then 1 to 2, then 3 and 4. So this is another traversal. Both are valid, as you can see, and you can formulate n number of like many traversals using a of many DFS traversal of a um, same graph. So now, as we know that, so we have discussed the traversal how many traversals can be possible and how can we do traversal. Now let us check how the adjacency list for the same. So this is the adjacency list for uh, the above graph. So yeah, so here 1 has connection with 2 and 5, then 2 has connection with 1, 3, 4, 5 has connection with 6, 7, 1. So this is like this. But now what we did was we were ignoring the uh, the nodes which are already been visited. Like suppose if we are at 1, we are going to 2 and 5. Now if we went to 2, then we have to go through 1 also, as 1 is in the adjacency list of 2. But we should not do that, then we will be looping infinitely. So to avoid that, there is a thing known as visited array. So what we can do is 7, yeah. So what we can do is 1 cos 7. Now, so now we have a visited array. Let us do, yes, 2. So on the top we are writing the indices 6 and 7, and okay. So what is this? This is visited, right? So these are the indexes, and this 0 shows that the current node is not visited yet, not have been visited yet. So now while traversing, so if we start from 1, and if we, so we are at 1, now we have to go either to 2 or 5. But as we traversed 1, then what we will do, we will just update this 0 to 1. That's it. So let's not do it this one messy. mm, yes. So just update this to 1. Then we are going to, now let us assume that we are at 2. So if we are at 2, update this to 1. Then we are at 2, then we have updated to 1. Then we have three nodes connected with 2, 1, 3 and 4. Then we will check in visited array. So 1 is already visited, then don't go there. Then go 3, go to 3. So 3 is not visited. So that is why we will, what we will do, we will go to, we will call DFS on 3. Now as we call DFS on 3, we have visited that particular node. So just make it 1. That means if 3 is also visited, then what we are going to do, we are at 3. Now 3 has only one node connected to it, which is 2. So go to 2, but 2 is already visited. So that the call is over. That means we are, we have attained the maximum depth possible to this particular branch. So nothing after 3, then just come to 2. Now we were at, while at 2, we were at 3, right? In like while going through all its connected nodes, we were at 3. 3 is also now visited. Then go to 4. 4 is not visited, but then we have to call DFS on 4. First we have to visit this, go to 4. 4 has 2, and 2 is also uh, visited already. So don't need to call. Now all the possible nodes from 4 are over. Then what we can do, we again come back to 2. So now 2, all the possible nodes of 2 are now visited. So again come back to 1. Now we are at 1. So 1 has 2 connections, 2. So 2 is visited. Now check for 5. 5 is not visited, go to 5. As we went to 5, we just update it to 1. Now we are at 5. 5 has 1, 7, 6 has their nodes, connected nodes. So 1 is visited, no need to worry. Then we have 7. 7 is not visited. Okay, go to 7. Oh, I have made some mistake. 7, 6. Okay. So as you can see, 7 is connected to 6 and 5 both. So we went to 7 first. As we just written it. Anything, any order you may follow. So now at 7, we will go to 5. Firstly, we will make visited 7 as 1. Now 5 is already visited. So go to 6. 6 is not visited. We will check for 6. Now uh, both of the possible nodes of 6 are visited as 5 and 7. Then we will go back to 7. Then 7 all are done. Then to 5, 5 to 1 and over. So this is the way we will do our DFS, which is depth first search. Here only thing we needed was our adjacency list, which will be given to us. No need to worry. And we have to use a what we have to use? We have to use a visited array, which will show us if the current node is visited or not. And like one thing you should know, if like here we were having our first node as 1, so that is why we used 1 based indexing. As you can see, this is the first index and we have stored 1. So generally what this index is, suppose VIS of 0, and we have used 1 base indexing. If the starting node was 1, then we should follow this thing, 0 1 2, 0 based index, what I'm saying. So that is the thing. Now let us check the code for particular. So so this is, here we have given a connected undirected graph, and perform DFS, use a recursive approach. As also I forgot to like say, give you approach. So as you all have might have guessed it by now, that at any given node we used to come to a particular node, then go for its the adjacency list, then call for all unvisited nodes and go to their adjacency list. And after all the calls are executed, then we used to come back to current uh, node. And similarly, so this approach says that it is a recursive in nature traversal. So what do I mean by that? Suppose we have called DFS on 1, then we will go to DFS 2, DFS 5. Now DFS2 will call to all its connected nodes, and after that it will come back. Then DFS1 will check, oh, I have another node which is 5, which is not visited yet. So go there. Then 5 will call 7, 6, and they will also return us after doing all the DFS from their side. So this is how the structure of code looks in case of DFS. So now this question, so we need to give a recursive approach for DFS traversal starting from 0th index. So as we discussed, what we used was 1 based indexing because our starting node was 1. Yeah. And in the question we require to use 0th vertex as starting node here is 0, as you can see in the diagram. And these are some examples. Okay, so now, so this is the code. Firstly, we have created a visited array and all values are 0 currently. Our start is 0, set as 0, as we have been told to starting from 0th vertex. Now this is the answer vector, as we have to output the DFS, the traversal, uh, in the vector format. So now this is the function call for DFS. So our arguments are adjacency matrix, which is already been given, then answer matrix, then visited array, and our starting index. So starting index was 0. Now, firstly, what we did, firstly we used to make our current whatever node we are at, we will make sure that it is made, it is one, it is make visited. So what is this task is doing is make it visited. Okay, and also at the same time we are just doing it, pushing it to our answer. Then we are traversing to all its connected nodes. So this is like for adjacency. In we are going to its corresponding adjacency list and the corresponding vector. So this, if our visited is 0, that means, so let me go back. So if we were at, suppose we assume an intermediate thing, if we are at 2, we have came to 2 from 1, right? So if we are at 2, we are not going to 1, we are going to 3, as we have already discussed, because 1 was already visited, and in visited matrix, it was made, visited array, it was made sure the value at 1 index is 1. So we should not go there. So that condition is, if visited is 0, that means it is not been yet visited, then call DFS on that index again. So just add, these are the arguments, and this is the current index or current node, whatever you may say, and we are just returning. So this, let me just submit. Actually I have already did, so it should get passed. So that's it for you. That is the DFS algorithm. Thank you.